Welcome back, it's MGL here. We're continuing with our cold water systems unit 305. We're now moving on to learner outcome 1.5. I do apologise, this video is going to be slightly longer than the last two, but it's because we're covering a lot of information. Remember, if you find this video helpful, drop a like, leave a comment, even hit that subscribe button and help support the channel. Right, by the end of this session, learners will be able to describe the main water treatment process and typical mains water distribution system from treatment works to the property. So we're going to be talking a lot about the treatment side of things. Cold water to the property. This water must be wholesome. I have put potable on there because I'm an old school plumber. It used to be called potable water, but now it's called wholesome water. Remember, fresh, clean water which is fit for human consumption is called wholesome or potable. So it depends how old the plumber is that you're talking to, whether they use the term wholesome or potable, but they mean exactly the same. So please bear that in mind. And the reason why I'm also talking about potable and wholesome is there are still some questions in City and Guilds that ask you either potable or wholesome. They haven't quite updated them all yet, so they still use some terminology. Right, I've got a question for you. Who is responsible for the collection, treatment and distribution of water to the consumer? Please write your comments below. If you think you know the answer, please put them down there. Pause the video, put your answer in. Let's see if you can get it correct. Write it on a bit of paper if you don't want to put it in the comments. Just have a go. What do you think the answer is? So who is responsible for the collection, treatment and distribution of the water to the consumer? Right, so the answer is the water authority or water undertakers. So whoever is supplying you your water, that is who is responsible for the collection, the treatment and distribution of water to the consumer. Right, before it is considered wholesome, water undergoes several stages of treatment to make sure it is clean and wholesome and able for good quality for you to drink. This is sedimentation, filtration and sterilisation. These stages are responsible by the undertaker. So the undertaker will do all this to that water. Right, so sedimentation. Sedimentation just means where we let molecules fall down to the bottom. So we try and clean the water and let it naturally, all the heavier objects filter down to the bottom of wherever we're storing it. So rainwater collects and stored in lakes and reservoirs where it is allowed to remain undisturbed. So we're basically just letting it sit there. So any of the soil that has got washed away with the water, remember we said the water is a dissolvent and it will dissolve certain things away. So some grit will get there, mud will get in there, decaying vegetation, all that kind of stuff. And we just let it sink to the bottom. This is known as a primary sedimentation. Storage also has an effect of reducing the bacterial concentration in that water. So basically it's going down and it naturally kills off most things. From here the water is pumped to storage reservoirs through coarse strainers and it is held in sedimentation tanks where further sedimentation takes place before being filtered. Because when we pump it from the reservoir, it may disturb a bit of sedimentation and bring it along with us. So we filter out as much as we can and then we got the smaller bits left over, but we let them fall as well. But we do other stuff to it. Now, this bit's going to be hard for me to say some of these words, but I will give it my best shot. Right. Coagulation. Right, coagulation. Why is coagulation important in water treatment? So again, if you think you know the answer, put them in the comments below. If you're feeling shy though, write down on a bit of paper what you think that answer is. I warn you, it's quite a long one. Right, so why is coagulation important in water treatment? So the answer would be coagulation does not guarantee safe drinking water, but it's still an essential part of the water treatment process. It removes suspended substances that make the water difficult to properly treat with a disinfectant and means that less chlorine can be added to disinfect the water. So it's making it safer basically. So we try and get as much debris or sediments out of it as we can. So we use this treatment to get that out of the water, which means then we use less chlorine, which also means it doesn't cost as much to the water undertaker to treat. So, coagulation. Right, I'm going to apologise now. This could be some good words coming out here. I might not say them properly straight away, but I'll give it my best shot. Right, so the coagulant liquid, let me get my little pointer here, is dropped into the water at the correct dosage. We've got all the impurities in that water, so the coagulant absorbs them impurities and it basically sticks them all together, which then makes them very heavy, which then, this is the word I've not been looking for, flocks are made and formed and they settle down, so it's flocculant. This is a process that is called flocculant. Right, coagulant and flocculantation are essential components of drinking water and wastewater treatment. They provide a reliable process for treating water tubility. Tubility just means that it's cloudy, hazy, there's bits in it, you can't see through it. You can get little tubes that you can test, and there's a little target at the bottom, and you look down the tube and you fill it up with water. If you can't see the target, you keep emptying water out until you see the target, and then it tells you how many parts per million of matter there is in that water. So, tubility, another key word to try and remember. This is a key test of water quality. All right, so we will look down this tube, we will see the water quality. If it is bad, we will use the coagulant treatment and help clean the water. Right, so how the water companies do it is they've got these little mixing blades here. The water comes in, it's mixed up with the coagulant, it fluctuates in this next one, and it helps stick it together. And again, there's a little mixing blade there. Then it goes into a sediment tank, and all that sludge falls to the bottom, and then the treated water goes off to its next stage. They then pump or get rid of this by some form of pump or cleaning agents, so it doesn't just keep building up. A sediment tank. So once it goes to this sediment tank, this is what the sediment tank looks like. Okay, so here is the sediment tank. You've got your intake valve. This lets the water down into here to the bottom. We've got the fluctuant falling down, so at the bottom you've got an extract pump, so as I say there, and it can go there. And it can be pumped and cleaned, but if there is any sludge that remains, we have what's known as a sludge blanket level. This sludge blanket basically levels it all out and stops any really big particles of fluctuant coming up where it can cause problems. And then you've got this sludge collecting cone as well, so that all goes into there. I'm doing hand gestures, but you can't see it. But that'll all go into there, and again, it can be automatically removed and got rid of through that. And then the clean water comes up and then goes to the next channel and the next process. So again, I would say stop this video, draw that out, make sure you've got all the correct labels. It'll help you remember this at a later date. Right, so now we're going to move on to filtration. Now filtration, my little pointer's in the way. Filtration can be done in several different ways. So I'm just going to go through a couple of them for now. So filtration, we have a slow sand filter. This is the most common filtration that most people use. It basically, water flows over the graded sand bed and it just goes through it. Right, the top layer of the bed provided with a large colony of budgeted algae growing on top of it, which forms naturally. It's known as smush stick. I'm sure I'm not saying it properly, but it's known as a smudge stick layer. And you're supposed to clean that off at least once a month or something like that. But it naturally builds up, okay? This algae assists in the purification of the water, okay? So it helps filter it. It basically builds up and it slowly eats any miniature bacteria, things like that, that it can get its hands on. So it's known as smush stick. But this is basically, again, what the system looks like. So you've got your dirty water. Basically, this is the water coming from that sediment tank. So it goes along to the next stage. So we got it's still dirty water. It goes through a slow sand filter, then it goes to gravel, and then it goes to this clean water, goes into another channel, and it goes off to where it needs to go to next. The smush stick layer builds up here. basically. It just builds up there. And it just gets that little bacterias out. I don't know what's happening here. Oh, there we go. My little pointer was playing silly buggers. It just helps get any microorganisms out and helps clean that water. But again, you must remember it gets cleaned out every so often to help grow some more fresh stuff. If it's left in there for too long though, it can pollute the water. So next one is known as a rapid sand filter. This is the one most water undertakers use. It's a lot quicker processed and it's done under pressure. It requires frequent maintenance, so it needs to be backwashed to make sure it's cleaned regularly. Usually they'll automatically do this. So this is what this system looks like. So your dirty water comes through this side, it goes through that graded sand again, and then eventually it comes out the bottom, and the clean water, oh, there we go, goes through this way. So we have a compressed air line here. I'll explain that one in a minute. So that clean water goes off in that direction. Now, how they backwash this is we would isolate the valve on D and open up the drain here, and we would pump air through into here, so it bubbles and aerates your sand and gravels, so all the debris gets cleaned out to the top, and then we keep doing that until the water is running clean again, and then they shut that one down, turn the air off, reopen that valve and carry on the process again. So the backwash as well, we would turn off A and open B, and that would go down the drain. Nice easy process, but again this is usually automated and it's done on a frequent basis, and they will have lots of these sand filter sets along the line. So whilst one's being cleaned, the other ones will be taking over the process. So that is a rapid sand filter. Again, I would recommend drawing these out, or finding them in your City and Guilds book that I told you to buy, and labelling the page so you know where they are. Right, so the next stage of this, once it's gone through the infiltrations, we will then can finally sterilise this water. Chlorine is the preferred method. You can use ozone. This is becoming now popular, but we tend to stick with the chlorine. So just to help kill off any bacteria that we've missed through the filters. Okay, we can use a UV light as well. That will do the same sort of process. But water companies tend to stick with the chlorine. That does sterilise the water and it's a more reliable method. Again, they are normally done in this method here. It is usually automatically controlled because trying to get the dosing correct would be very hard work for us to do all the time. So it's usually done by a computer of some description. So it's automated. So we've got our water going into there. We've got our mixing control. That then gets diluted into this bit, and then it goes off to our mains, and it gets it squirted off to wherever it needs to go through the mains to everybody's house. Sometimes the chlorine levels will be a bit higher. Sometimes the chlorine levels are a bit lower. It just depends how close you are to the plant. So now the plant itself, once we've got all these stages in place, it kind of looks like this. So we go from our water source, our reservoirs, our rivers, wherever it wants to come from. It goes through the intake screen, so we try and take out some of the bigger particles as we can. Then it goes to a low lift pump, which pumps it along. We put the coagulant in. It goes through our first mixing tank, flocculation tank here, which then spins it all round, mixes it up, helps that chemical bind all them particles that we don't want. Then it goes into our sediment tank where all the bad stuff goes down here, so the dirty water is got rid of, and the cleaner water goes to the next stage, which would be our rapid sand filter or slow sand filter. So the mucky water again would go down here, goes down there. Once it's gone through the filter, it then goes to the clean well, and then we go to the next stage where we have the disinfectant being put in. And then it goes to the high lift or the boost pump, which then sends that clean water off to wherever it needs to go, down the various distribution systems. So again, find that in the book if you can. If you can't, I would take a picture or draw this one out. It's totally up to you. So if you want to pause the video, do so now and make a copy. there is basically, I think, the end of this one. So I hope you found it useful. If you do have any questions, please remember, pop them down. Just don't get me to say that word again, please. Pop them down in the comments and I will answer them as soon as I possibly can. If you have found this video useful, please remember, drop a like, leave a comment, even hit that subscribe and help support this channel. Thank you for watching. It has been a pleasure as always, and I will catch you in the next video. Bye bye.